This is 2.2, day 2, part 1. Yesterday we focused on the zeros of the function and finding the end behavior. Remember, the x-intercepts are the zeros of the function. This first slide, there's just a couple things that I want you to write down. So, yesterday in that problem we had a repeated zero when we had the x squared. Depending on the exponent of that repeated zero is going to do one of two things. This is what I do want you to write down. A repeated zero. Write that down. And then write down x minus a to the k is a factor of the function. So write that down. Then there's two scenarios for a repeated zero. If that exponent is an odd, then what happens, it crosses the x-axis. And we'll look at it in the example below. It crosses the x-axis. So it goes through the x-axis. So think about horizontal x-axis. If the k is even, which that was the example yesterday, then it touches the x-axis but doesn't go through it. So I call those the bounces that happen. Does not cross the x-axis. There's going to be a bounce. So go ahead and write down those things that I've underlined. And then we'll look at an example. And you can choose if you want to write the example down or not. So the example below is a 7th degree polynomial. So it's a snake still. And what they've done is they factored it out already, this example. And notice there are repeated zeros going on. So the first factored is x minus 2 raised to the third power. So when we solve that for x, to find the x-intercepts, we would set that function equal to 0 and solve for x. We get a 0 at 2, which is an x-intercept right here. Now look at the multiplicity, which is like the power. The power is 3. So now let's go up to that chart that I had you underline in the red. Since the power is 3, it's odd. That means it gets to touch the x-axis and go through it. Change colors here. Then we have another repeated 0. If I solve that for x, I get -1. Its function, the exponent for k, is even. It touches the x-axis but doesn't go through it. So here is my -1, it cannot go through this line. So if I kind of think about, here is my function, it's increasing, it cannot go back through it. It's telling me it has to stop and go back down. It has to go back down. It cannot go through this x-axis. But this one in the green It rises, there's the x-intercept, and now since there is a repeated 0 and the k is odd, it continues and it can go through that x-axis. So that kind of helps us with today's graphing. Yes, sir?
How do you tell like which one goes first? Like, you see how the green went second?
Because this is, the x-intercept is a 2. And then we talked about end behavior yesterday. The end behavior, when we would FOIL that back out, is telling me it's going to rise on the right, and it's falling on the left. And then I have something happening between those two x-intercepts to give us the snake, because anything that's odd is a shape of a snake in its degree. And then I'm going to kind of go quickly through this next 2 slides because I'm going to do 2 problems with you instead. But I just want you to see how they explain it out. So yesterday, we focused on this first kind of slide. Didn't focus on the multiplicity, which is fine. So don't write any of this next 2 slides down. I'll give you 2 practice problems. You can choose which one you want to write down. So here's a function. It's not in standard form. So I recommend that you put it in standard form so you have your x to the 4th first. So think about the shape right now. When it's degree of 4, what would it be? What's the shape we call those? It's a quartic function. Anything that's even, the m or the w. It's either going to look like this, it's going to look like that. The leading coefficient is a negative. And they use their notation a little bit differently on this slide than what we do. We just call it rises and falls left and right. So my degree is even 4, and my leading coefficient is negative. So my graph is going to fall on the left and fall on the right. So I know my graph has to look like this M, the McDonald's. Then it went down and factored it. So we factor it, and we know we can have up to 4 zeros because the degree is 4. They factor it, and then they set those factors equal to 0 and solve for x. So you're going to get a repeated 0 right here. And look at the repeated 0. The repeated 0's k is even. So if we go back to this slide, if the k is even, what does it tell me? It does not cross the x-axis. So what they do is they start to graph what we know. We know the end behavior is falling on the right. It's falling on the left. It has x-intercepts of -2, 0, and 2. And this is a repeated 0, which is even, and it cannot go through it. So what do you think is going to happen in between here and here? It's going to come up, and it's going to come up. What they do on the next slides is they check for symmetry. Remember we checked for symmetry where we substitute a negative into the function? And in this case, they check it, and it's symmetric about the y-axis. Don't worry, we're going to go through this in an example in more detail. Then they just plot a few additional points. How you find those additional points is you evaluate the function. So if I substitute 1.5 into this function, I will get 3.9. So now I have a little bit more information. Now it's symmetric about the y-axis. So what does that mean? There must be another one right over here. Then they did another one. They did 0.5. They picked just another number in between the x-intercept, because there's an x-intercept here at -2 and then at 0. So we want to figure out what happens between those 2 points. So they're evaluating the function again. Well, there's symmetry, so those 2 points have to be symmetric. And then there's that x-intercept again. So now we see the W, the M, not the W. All right. The next slide, you can choose. Okay, so we're going to stop there, and we'll pick up with the next movie.